So it's 3 o'clock. Let's start the presentation. Thank you all guys for coming here for the presentation. And today I'll tell you about stage 1 C2 in 3 days with Mythic. Short information about me. I'm senior penetration tester at Kaspersky, and my passion is C2 frameworks. This is our agenda for today. First of all, I will tell you the motivation for this talk. Then we will share, I will share the problem that our team faced, and I will give you the idea and the solution for the problem, and I will provide you some examples how you can create your own C2 and agent, and I will give you some examples. And the final step is conclusion. Okay, let's begin. So the first point is I want to inspire you, because if you can create your own agent for pen testing, for red teaming, you will deeply understand the process and it will really help you. The second thing is I want to share our experience with the community, and I want to get a feedback from you guys. Yeah, by the way, who of you guys conduct penetration testing? Please raise your hands, or red teaming exercises. Okay, some of you, okay. In that case, I will explain more details, so everyone will be on the same page. Let's continue. So the problem is the following. As a penetration tester, you face with the following problem. As soon as a tool becomes really popular among bad guys, it becomes unusable. And you cannot use it on your project. You need to spend a lot of time to prepare it. So, for example, we have a Metasploit interpreter, and it has more than 230 signatures in the Microsoft database of, antivirus. So you cannot use it like on your penetration testing project. And the Cobalt Strike is a really great tool. It has a lot of ways how you can customize it. However, it is like everyone uses it, and in that way it becomes a benchmark. So if a blue team can detect Cobalt Strike, it means this is a good blue team. However, you need to spend a lot of time to customize it. So, for example, Cobalt Strike has a functionality such as string replace, so you can replace signatures. However, these bytes are not replaceable. You cannot do that in version 4.9. So, and you can, in that case, you cannot evade the defensive solutions for your project. Okay, the other thing that you can use, for example, open source tools. The Sliver C2 framework, which is really good one, because it has a lot of functionality, it has armory, so a lot of tools, a lot of usability. However, I received a feedback from my colleagues and friends that it has stability issues, so sometimes your agent just die and you have to start from the very beginning. The second thing is when we tested this framework, it did not support Windows proxy. So it means that if you are on a social engineering engagement and you send your payload and your customer uses Windows proxy, so corporate proxy for DPI and so on, that means it will not work. Like a year ago, they fixed it, so now it is not the problem, but at that time, we faced the problem. And also, the implant size. The language is Golang, so the implant size is 9 megabytes, which means we are limited in social engineering scenarios. There are some new C2 frameworks like Havoc, but it also has some operational security issues and stability. So so the problem is like we need something new for us, like custom. However, we cannot write everything from scratch, and this is like a big problem. So we decided to eat the whale in chunks. First, we decided to split our payload on stages, and then on some stages we can reuse open source solutions, and some of them should be written from scratch. So this is how we split our payload. In that thing, the stage 1 will be responsible for initial payload execution. It should contain different forms, so you will be flexible. For example, you want to send an XLS macros, or you need to run it from a shellcode or web shell. So it should have different ways to launch your payload. And at the same time, it should have defense bypass mechanisms. And this stage should be written from scratch, so you need to spend some time on it. On the other side, the stage 2, it may be used like completely open source with small obfuscations. And something in the middle, what we did with this stage, we did some research, what we have. We combined the best parts and create something new. So I will share it how we did it. The stage 1 will be responsible for situational awareness stage. So you have launched your payload and you need to look around and you need to make informed decisions. So what you need to do, what you need to launch. And also it will be responsible for persistence. So you need to have different ways how your agent communicates with a server. For example, HTTP, TCP, or some covered channels like Slack or any other. So based on the functionality, we wrote down some requirements. The first requirement is called dynamic functionality. It means that as soon as a new technique appears, you need to use it on your project. Because you need to use cutting-edge technologies. So the second thing is that since we want to be flexible, we need to maintain small size, and we need to have minimum footprint. We also don't forget about operational security. So we don't want to be noisy, and we need to have different transport. It means that we want to use HTTP, WebSockets, and other things. And also, after we look around, we find weak points in the infrastructure. We can launch the second stage to execute lateral movement and exfiltration and other steps. So we looked around like 5 years ago, there was a C2 framework which was called Covenant. Now it is completely dead, but it has a really interesting idea. Every action was executing an executable. It means that you have a source code. When you type something, the source code was compiled at runtime and sent to the agent. And for example, you type who am I. It doesn't mean that I'm running whoami.exe. It means that I'm running an .NET assembly. And this thing was stealthy. That means that at that time, it was difficult to detect it. Now it is dead, but the idea was really interesting. The second thing is like 3 years ago, Cobalt Strike introduced a thing which is called beacon object file. This one is also today quite popular and cool technique, which we may let's say, borrow this idea for our stage 1 agent. And the third part is Mythic. This is a really cool C2 framework with microservices architecture. So you can adapt anything you want, and it is really flexible. So let's take the best part of it and create a really simple agent. So what it does, it just pulls the object file, executes it, and sends the response back. And that's it. So if we remember the requirements, they are all fit because you can write your object file with any functionality and adapt any technique you want. If you are using a small, if you want to get a small size, you may use low language like C or C++. Since we are using Mythic, we can adapt any transport, HTTP, TCP, Dropbox, whatever. And you should, since we have like beacon object files, we can launch the second stage like open source tools. So now I will give you some background, what I was like more details about the things that we are using. After that, I will give you a demo, and then I will explain what happened on the demo. So this is a Mythic traffic flow diagram, but please don't be afraid of that, because as an operator, you need to be focused only on this part. The first part is called payload container. This is a Docker container that contains your source code, and it should build your agent. That's it. So you put a source code of your agent to the Docker container. And the second thing is C2 profile container. If we are talking in terms of CobbleStrike, it's like a listener. So this container listens on HTTP port, receives commands, receives information from the agent, and shows the result to the operator here. And this one, you don't need like deeply understand this stuff, at least for now. The second thing is object file. This is like a low-level stuff, but I will not cover the full mechanism, just briefly. So object file means that if you have a small portion of a C code and then you compile it, it is not the final version of the program. So if you resolve, and it has several steps. For example, you need to handle relocations here. Then you need to resolve some symbols, and then you need to load some missing libraries. And after that, you can just execute it like a normal portable executable. So this is a cool technique that was developed by CobbleStrike company. So that is our idea, and we have an open source implementation of this technique from guys of Trusted Sec. So we can just borrow this part and then combine everything. So why it is called beacon object file? Well, when you have an agent, and for example, you have a set of APIs that you want to use. For example, this one is called beacon printf. Printf, in terms of like C, means that I want to print some characters, like hello world. But this one means that I want, from my agent, I want to receive a response. Like, it doesn't mean I'm printing to the console. It means that I'm sending back, using my transport, some portion of information. So there are really huge advantages of this technique because the size of a command is really small. For example, if you want to execute whoami.exe, the size will be 80 kilobytes. But if you are using object files, it will be 7 kilobytes. It's like 10 times. This is huge in terms of like strange transport. The second thing is lighter footprint. This one is the most important. this is an example. For example, you have a phishing, no, let's say you have a web shell on a Windows server, and you launch the command who am I. So at this like default cmd who am I, cmd/c who am I, and that thing, what happens next? The process of the web server spawns cmd, and then cmd spawns whoami.exe. This is a really bad stuff, because the security operations center will see, why web server wants to know who is he? Like, this is strange. And like in a couple of hours, they will throw out you, delete your web shell, and fix the vulnerability that you just discovered. So this is that's why we have a lighter footprint, because we are not spawning new processes. And it is a really good idea to stay in the current process. And you can write almost anything you want. So, but it has its own limitations. Since the context is the same, if you don't write the C code carefully, you may have such errors like memory access violation or kind of that. In that case, it will crash and you will lose your access. So you need to write this thing really carefully. So, and when it executes relocations and all this low-level stuff, it relies on virtual alloc. This is not bad, but any of you met with ETWTI? Okay, only one. Okay, this is a like kernel level callbacks, and antivirus or EDR will, as soon as you call this stuff or any other malicious functions, let's say malicious, but they are not malicious, but bad guys often use it. So as soon as you call this function, the defensive solution come to you and start scanning. So this is a thing that you need to remember and to evade for evasion. And also, the pattern for the beacon object file is also should be met, because you cannot run long-running tasks, because while you're executing an object file, it is blocked, and you cannot do two tasks at the same time. Yeah, so if you want a long-running task, you need to have some kind of process injection. This is a demo, and after that, I explain what happens. So this is my agent. Here, I'm typing inline execute, which is send object file and execute it. Then I'm typing whoami.x64.object, and I'm passing no arguments, and I get the result. So this is completely different from whoami.exe. And let me explain what happens inside. Yeah, this is completely different, as I told you, with whoami.exe. So how it works? First, you need to host the object file on a server. Well, first you need to write your object file or find it online somewhere, because, well, there are a lot of such portions of C code or object files. You can use any of them, but you need to host it on a Mythic server. After, you can use like this button or scripting API, which is more convenient. After that, you need to write a Python file for your Docker container that I discovered earlier. This is a class. This is the first class. And in this class, you need to describe arguments for the command. Like, this is an object file, some description here, and this is a second argument. So there are quite a lot of examples how you can do that, but it doesn't require a lot of time. Just copy, paste, and rename these things. Next, you need to create the second class in Python. You need to provide the description and the command itself. So if you type it here, now you have a new command in your agent. And after that, this is the final part. You need to use Mythic RPC, which is a Python-based RPC to interact with Mythic. And you need to retrieve the content and send it to the agent. As a result, you will see in your Wireshark this type of JSON. The first one will be your arguments, and the second one will be the base64 encoded object file. So you want to send this JSON to your agent. How you can do that? Let's examine it using the HTTP profile. Any of you guys developers? Okay. So in this diagram, you need to focus, as an agent creator, you need to focus on these two things. This is how the agent communicates with Mythic, and this is how container is responsible for decryption of the traffic. And the communication protocol is really simple because you send request, you get response, and that's it. And so, but there is a small detail which is really important. When you communicate with the Mythic server, you need to get a payload UUID which is unique for every agent. It means, and after that, you need to concatenate with your CMD request. So what you do, first you have your JSON with the request, then you may encrypt it if you want. If you don't want, you may use another type of encryption, for example, IIS and so on and so forth. After that, you concatenate the unique ID, then you encode it and send to the server. Server will process it, and this is how the encryption happens. You need to write a separate Python file in a Docker container, which basically decrypts this portion of a command. Now, this is a small recap of the idea. And what you need to do on the agent side, you need to take the JSON, this one, and you need to take the COF loader from the trusted sec. You need to take these arguments and pass it to that project. And that's it, I think. And you can do it like in 3 days, like in 1 day, okay. But you will still face with different problems. For example, typing this type of information is not usable, especially if you are on your project or engagement, and because you can have a typo or any problem. So there is what you can do, you can give a naming convention for this thing, so to skip the architecture. And also you can pass the first part of argument as a file name, and the rest of the string will be arguments for the object file. This one could be more useful. For example, here I'm using I want to know the processes of a server, and it could be usable, but still in some cases it is not. For example, here I need to write the type of the argument, which is also tedious. So in that case, I will demonstrate later how you can manage this problem. But the most another problem here is that, well, since the object file is a C code, it is really essential to have the correct order. For example, here I'm sending the white char and then short. And if I miss it, the right order, the agent will just crash and I will lose the access to the server. So in that case, also we need to prepare the arguments in that way. So this is arguments, and then you need to transform it in this way. Because this thing called length prefix blob, and you need it to pass it as a single argument. So how you can manage that? Another example. So I want to dump LSISS process to extract credentials from Windows memory. So there is an object file. It is public nanodump, also by Cluj-Napoca, and which dumps this process. But it requires like 10 or 11 arguments, and typing this stuff is really tedious. So how you can do what you can do? You can just look around and see how the Cluj-Napoca did. They have a thing which is called Cortana scripting. What they actually do, they first set some defaults, so you don't have null pointer exception. Then they like prepare some defaults. They have some description and TTPs highlighting. Then they convert the arguments in a special way. Here, capital Z means white char and the S means short. And after that, they do the same. They execute inline the object file. So let's do the same thing using Python and Mythic. First, we set some default values to the earlier class. As a result, in our web interface, we receive this type of window with 2 arguments and default values. Then let's add some description here and how you can use the command and some attack mapping. So now the Mitre matrix is shining like a Christmas tree. And after that, we need to pack the arguments for the command. So here and here. But the order is really important here. If you miss the order, your agent will be crashed. Yeah. And the final command will be inline execute. This one is the same, but I'm here checking for the and validating the input and preparing the arguments. But this one is kind of default, so it's not. It is almost the same as the previous one. So as a result, now you have a command which lists a directory. So, and yeah, this is an example of the first task creation. But you still have a problem because you cannot pass binary arguments as in that way. So if you have a shellcode, what you're gonna do? You don't want to type the shellcode on your keyboard. So you may use the same pattern. You need to host it and then at runtime retrieve from the server. So this is an example here. So I'm trying to inject a shellcode into a process here, and I'm just providing a name, and later I will describe how it happens inside. So you need to modify the first Python class, and you need to add the following argument, which is called dynamic query function, and the name of the function. So what it creates a drop-down list with the list of shellcodes that you host on a Mythic server. And this is a function which basically retrieves the files that have .bin extension. Like if the file ends with a .bin, then we assume that this is a shellcode and we can inject it. So this is a demo, for example. Okay, works. Yeah, so I'm trying to inject a shellcode into another process. And here I have a process ID that I want to inject my shellcode. And this is a drop-down list that I just I've just told you about. So I have injected the payload here, and here I have received a new callback in a new context of process. So this is how you can move from one process to another to receive a new context. And now I can, for example, type other commands like who am I, ipconfig, and so on. So let's go next. Since we want to have or to execute situational awareness, we may reuse the GhostPack tool or .NET assemblies using also object files. And also we have a drawback here because we need to load CLR or common language runtime. But if you inject into a correct process with already CLR loaded, or you need to, or you can find a way how you can manage this problem, it is really good way to extend the functionality. For example, I want to execute here a seatbelt, which is like a really popular tool to quickly grab information about computer, what it has, what certificates, what directories. Here I have a screenshot of Rubius, and this is a demo of seatbelt execution. So in that way, you also need to create different Python file with the whole description of arguments, and then you need to host the exe file on your server, and after that you can you don't see it, but the command is like execute assembly and the assembly name and the arguments. And as a result, you get a really huge amount of information that you may use during your penetration testing or red team exercises. Let's go next. Since we want to maintain persistence, sometimes we need to upload a new file or download something. So for example, you want to drop a DLL on your host or something like that. So the file upload and download process is completely different from the CobbleStrike. So let's discuss it based on the screenshot, because it is almost the same, except only one flag. So the first thing that happens, you type it download and the file name like some text.txt, and then the agent comes to the server and he says, okay, I have a task. I need to check if I can read the file and if I can grab it. And then if everything is okay, it returns to the server and says, okay, I have a file for you. Please give me the ID for the file. The server gives the unique ID for the file. And after that, the agent should push it to the server using as separate chunks. So if we go a bit deeper, this is how it looks like. This is a JSON with some unique ID, but the only difference with the screenshot here is like true or false. This one is not like critical. The download will be the same. So you provide this information, you send it to the server. Server gives you unique ID, and after that you just push this JSON with base64 encoded screenshot or file on a server. So there are two ways how you can do that. The first one, you can change the whole structure of an agent. For example, you can create an if condition. For example, if the command equals make a screenshot, then you do this. Or if you have like execute object file, you do this. But this is, we decided not to do that because it will add more ways how it can be detected and more functionality. So in that case, we lose the flexibility. In that case, we decided to write our own object file, and to do that, we have added 2 APIs to handle this type of commands. The first one is you need to get the unique ID of a task. Otherwise, the server will not be able to differentiate between the tasks and responses from a server or from an agent. And the second thing is I have added beacon send raw response. It means it will just forward the response to the server using the transport. For example, if you are using HTTP, it will just forward the whole transport to the whole answer to the HTTP. And on an object file, if you are creating your object file, you need to add the same thing, just saying that it is imported functions. So as a result of this, we did the same, and on a separate tab, the screenshot appears. But it is not convenient to switch tabs between when you are on engagement. And there is another improvement for this thing. These are tabs here. So there is another improvement which is called browser scripting. So basically, it is a way to process response of an agent. So you can write JavaScript and create something inside your web page. So it just takes the file ID and retrieves the screenshot here. So for example, I'm typing here screenshot. The command is sent to the agent. After that, agent sends back the screenshot, and I can click a button and get the screenshot without switching to another tab, which is more convenient. So this is a short summary for the presentation. Let's take Mythic C2. Let's take COF loader that combine them together. On top of that, let's put some beacon object files that are online. Let's create something that we need, and that's and we receive our own agent which will not be detected. Another important thing that you need to remember when writing your own agent is you need to resolve Win API at runtime. So if you want to send request, don't forget about that. Also, you need to think about control flow obfuscation, which could be important in some points. And also, since we are relying on virtual alloc, you need to rename strings. So in your memory, you do not want to have beacon printf or beacon something, because it's almost in every defensive solution you have such a signature. It is worth to spend time on researching on injection primitives, how you can inject a shellcode into a process, and how you can encrypt and decrypt your payload at runtime, while sleeping. These are some useful links that were used today, so you can get them, read the documentation, combine everything, and create a new agent. And some pros and cons of this approach. So the first thing is, since the Mythic is modular, you can easily adapt techniques that come every day, and you can use everything you want. It is really flexible. You can use any transport. For example, it supports such type of transport as Discord. So it means it doesn't send HTTP request. It sends message to the Discord. Then agent reads these messages. Okay, I need to execute who am I. Then it sends message in Discord. Okay, here is the result of who am I, and that's it. This is like a covered channel. And also you can create your own easily using this C2 framework. You can easily integrate, but and it is really useful for customers because when you are on red team engagement, you need to track all your actions, and you can easily track it using this framework also. And the really huge advantage that it has really well documented structure, and the documentation is really great, so you can read it and understand everything. The cons that I faced was that debugging could be not easy, because since you have different parts of Mythic, it has microservices architecture. Sometimes you cannot understand why it's not working, and you need to debug different Docker containers separately, which is a bit painful. And that's it. I'm ready to answer your questions.
Question regarding stage 0,
Mm-hmm.
where you said you try to bypass execution guard rails.
Uh-huh.
So I'm curious about what tools you use, or what living of the land techniques you use, imagining a system where it might have, like, let's say, Windows Defender running APT and app locker and AMC and PowerShell in limited mode. What is the technique that you go to most of the time?
Okay, the best technique that I go most of the time is reconnaissance. So sometimes we do such thing like a reconnaissance phishing, which doesn't contain any malicious attachment. It will just grab the information, meta information about the computer, so we can create the stage 0 correctly based on this information. And also really depends on your scenario. For example, if you're running on a web shell, it could be a bit easier. But the problem with, for example, that Microsoft Defender anti-APT heavily relies on ETWTI, which is not easy to evade due to the kernel level callbacks. That's why you need to have a stand, like a lab with it, and test it on your own infrastructure, and then you can use it on a customer's infrastructure. So that's a like general answer.
Thank you.
Thank you for your presentation. My question is, considering Cobalt Strike, it has some usual ports that interact with the machine. Does Mythic has the same ports? Maybe to block them or to defend against Mythic from a blue team perspective?
Okay. Well, you cannot. So the question is that the Cobalt Strike has some ports that are used during the engagement on a network level. And is it possible to detect Mythic using this network level? The simple answer could be you can detect Mythic, but it depends on how I write my own agent. If I use something unusual or new, you will need to catch it, like you will need to catch it on the behavior based. Like, for example, if a computer from HR department requests something on a network management segment, you need to detect that type of stuff. But on the ports, I think you cannot like easily detect that, because it depends on my actions. If I make a mistake, then you detect it. If I do it like in a correct way, then it would be hard to detect. Okay, I think if you have any other questions, welcome. I'll be here or near the stands over there, so you can just come to me and ask any questions you want. Please welcome. So that's it. Thank you.